What's going on YouTube? Coach Carr back again, giving you another midterm review. We are going to continue on from where we left off, and I hope you enjoy. Okay, so last video, we did not get through all of page 5. So the last problem that we have is number 16 on that page. It says find the measure of the vertex angle. So first thing I want to look at is, let's look at these markings. So these slashes tell me that both sides are congruent. Now the only triangle that I know of that has the two sides congruent is an isosceles triangle. And an isosceles triangle, then one of the things we also know is that the base angles are going to be congruent. So when you have an isosceles, again, you're going to have congruent base angles. Now, that when they're congruent, that means they're equal. So what I'm going to do is do 8x minus 55 equals 5x minus 7. So now I'm trying to get x by itself. So what I am going to do is I'm going to subtract 5x from both sides. And just to save room, I'm also going to do my adding of 55 to both sides at the same time. So this will cancel out the 55 on this side, and it will cancel out the 5x on this side. So now you have 3x equals 48. Divide each side by 3 because I'm trying to get x by itself, so it cancels out the 3 on that side. And you're left with x equals 16. So x is 16. Now, they want us to find the vertex angle. The vertex angle is up here. So I don't have an equation for that. So what I'm going to do is actually plug x into one of these equations. I'm going to plug it into the 5x minus 7. So 5x minus 7. Instead of x, we now have 16. So 5 times 16 minus 7. 5 times 16 is 80. And then that's minus 7, which is 73. So these ones are 73 degrees, and they're congruent, so this one's also 73 degrees. So now the way I am going to actually find my vertex angle is through triangle sum theorem. Triangle sum tells us that all angles inside a triangle have to add up to 180. So 73 plus 73. I don't know what this angle is, so I'm going to mark it as x. So plus x equals 180. So 73 plus 73 is 146. So I just added my like terms. So now what I want to do is subtract 146 from both sides because I'm trying to get x by itself. And now you have x equals 34 degrees. So our vertex angle is 34 degrees. Okay, so we're already on to page 6. This one is saying solve for x to determine what type of triangle this is, classified as acute, obtuse, or right, and isosceles, equilateral, scalene. So these ones are basing it off of its angles. These ones are basing it off of its sides. They tell us that angle A is 10x, angle B is 5x minus 17, and angle C is 7x minus 1. So first thing I like to do with any kind of word problem is draw it out. And I've been given plenty of space on this paper to draw this out. So I'm just going to draw a triangle. Now I don't know what the triangle is going to look like yet, so I just drew a basic triangle. And they said that we have angles A, B, and C. So I'm going to do A, B, and C. I'm going to label what I know, and that's what each angle's equation is. So A is 10x, B is 5x minus 17. And C is 7x minus 1. So I'm noticing that all these equations are angles. So all angles inside a triangle, we know what that is from triangle sum. So triangle sum theorem, if you don't remember from the videos before, is when you add up all the angles and they have to equal 180. So the way I'm going to set this up is 10x plus 5x minus 17 plus 7x minus 1 equals 180. So now what you want to do is combine your like terms. So 10x will combine with 5x, which will combine with 7x. And negative 17 will combine with negative 1. So what I'm going to have here is when I combine all the ones that have variables, I'm going to be having 22x, and negative 17 minus 1 is minus 18. And it's all still equal to 180. Now, add 18 to both sides. That's so it cancels out here. Now you have 22x equals 198. I want to get x by itself, so I'm going to divide by 22 to both sides, and that's so that it cancels out over here. So now I have x equals 9. So we've gotten part of our answer done. They say that x equals 9. Now I have to classify it. So like it even gives you a hint on this paper, and it says find all angle measures first. So if I need to do that, let's go ahead and find each one. So let's do A first. The equation for A was 10x. Well, now we know what x is, so I'm going to do 10 times 9. 10 times 9 is 90. So A is 90 degrees. Then you have to also find B. B was 5x minus 17. Well, instead of x, we now have 5 times 9 minus 17. So 45 minus 17. And that's going to equal 28. So angle B is 28 degrees. Then the last one, C, is going to be 7x minus 1. Instead of x, we have 9, so 7 times 9 minus 1. 63 minus 1 equals 62. So angle C is 62 degrees. So based on the angles, I have a 90-degree angle. So if I have a 90-degree angle, I am dealing with a right triangle. So I know it's going to be a right triangle. Now, all angles are different. So if all angles are different, that means all the sides will be different. So the only one that means all sides will be different is scalene. Now, I would have known if it was isosceles if 2 of them were congruent. I would have known if it was equilateral if all of them equaled 60. So again, since they were all different, it was scalene. So it's a right triangle and a scalene triangle. Okay, so now we're on page 7. This one says, what are the 5 possible ways for proving triangles are congruent? So this is pretty straightforward. The only ways that you can show that triangles are congruent is with side, 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 angle, side, angle, side, angle, and angle, angle, side, and last but not least, hypotenuse leg. To use hypotenuse leg, you have to have a right angle, but just because a triangle has a right angle does not mean it has to be hypotenuse leg. All right, so now we're on 19. It says determine which postulate proves the given triangles are congruent. If possible, draw on the necessary markings that are allowed to be assumed. So there are 2 things that can be assumed when you're dealing with triangle congruence if you see it. And one is reflexive sides. So reflexive sides are when they share the same side in a triangle. So if they're sharing the side, it would have to be congruent. The other thing that we can assume if we see it is vertical angles. So vertical angles are angles that are directly across from each other. So with both of these, in order to even have a chance to use either one, the triangles have to be touching. So I'm not going to do every single problem in here, but what I'm going to do is I'm just going to do the middle row so that you have an idea of how to do this. Now, this one here, you have the right angle, so we have an angle, and you have at least one side congruent. Now, this is actually one where I can assume something, and that's this side here that it's touching both triangles. So if it's touching both triangles, it has to be congruent for both. This is called reflexive. So this is reflexive property. Now, I have a 90-degree angle and I have a leg, and the longest side in a right angle, or a right triangle I should say, is going to be the hypotenuse. So this one is going to be hypotenuse leg. So that's how we prove triangle congruence. This one, the markings we have is an angle, a side, and a side. So something I've said in my class before, ass or ass backwards cannot prove triangle congruence. So this one can't be proven. So angle side side or side side angle cannot prove triangle congruence. So this one we can't prove it. The next one, we have an angle, and a side in both of these. So these can actually be done by angle, angle, side, because we were given the right angle, an angle, and the hypotenuse. So this is an example of where it had a right angle, but it wasn't actually hypotenuse leg, because we didn't know one of the legs. We did know the hypotenuse. Another thing I want you to notice is we didn't do angle, side, angle. And the reason for that is if I were to try to go from this angle to this side, I would have to skip a side and an angle to get there. We are trying to find the shortest way to get through all of them. So you can't skip a side and an angle. All right, little homies, we're on page 8, number 20. This one is filling out a 2-column proof. So we're dealing with a proof. So we're trying to prove something. So something I like to do is just fill in the stuff I know right away. So something I know or should know with a proof is that something has to be given. So the beginning of a proof is always given. So they've already have reason for given twice. So what I want to do is look at these statements up here. What was given to me is that MN is congruent to PO. So that's one of the things that was given. The next thing is you have MP is congruent to NO. So we were given two things, so I was able to already fill in part of the proof with just what's given to me. So now the last statement in a proof is always whatever you're trying to prove. So that's already given here. But notice that what we're trying to prove is that an angle is congruent to another angle. So in a proof, if you are not trying to prove that one triangle is congruent to another triangle, like you see here, that means the last one has to be CPCTC. So corresponding parts of congruent triangles are congruent. Now, most of us don't want to write that out, so that's why we put CPCTC. Okay, so now the only things we don't know and couldn't fill in yet is 3 and 4. So we're going to fill in 3 and 4 now. So number 3 says MO is congruent to MO. So that is not a typo. It is supposed to say the same exact thing is equal to each other. So because they are both sharing this side, And if you remember earlier, something that you can assume when you see it was that reflexive property. So what they're talking about is reflexive property. So now we're looking at the markings that we have in this picture. So what you want to do is kind of just look at one triangle at a time. So if I do that, what I have is a marking on the side, a marking on another side, and the marking we just made from the reflexive property. So we're dealing with 3 sides. And so that means triangle MNO is congruent to triangle MPO because of side, side, side. So now you have a completed proof. Okay, so now we're looking at number 21, the problem that can now officially drink. Fill in the 2-column proof. So remember the first thing that I said in the problem just before this. You always start with what's given to you. So they already have the reasons given in there. So let's go ahead and write what they told us was given. So WV, so the line WV is parallel to the line YZ. So I'm going to go ahead and draw that in here. Something I like to do whenever it says that the lines are parallel is to extend the lines that they're talking about. So WV I'm going to extend, and YZ I'm going to extend, so that I know which of my lines are supposed to be parallel. So these lines inside would end up being our transversals. Now, the other thing that was given to us is X is the midpoint of VY. So the line segment VY. So that was given to us. So VY has a midpoint of X. So that means each side has to be congruent. So I'm going to go ahead and put a marking there because I know both sides must be congruent because it's a midpoint. Notice that that's the only one I'm putting a marking on because that's the only one I was told has the midpoint. So what I'm going to look at here is number 3 says angle WVX. So WVX, so remember that the middle letter is the most important. So we're talking about angle V is congruent to angle ZYX. So ZYX, so this angle right here. So we're looking at this line here, the transversal. They're inside of these parallel lines. So you actually have an angle relationship for that. So again, we want to look at it like it's only having this transversal. So the angle relationship would be for this one is they're both inside of the parallel lines and they're on alternate sides of the transversal. So we have alternate interior angles. So that's how we knew they are congruent. The next one says VX, so the line segment VX is congruent to the line segment XY. I already have my markings there. The reason is because earlier in the given we were told that it was the midpoint, X is the midpoint of that line. So the reason we knew that these were congruent is from the definition of midpoint. So if you ever see midpoint in the given, you know definition of midpoint has to be at least one of your answers. Then the next thing it says is angle VXW, so this angle right here, is congruent to YXZ. So the reason these ones are congruent is actually from something that you could assume if you saw this picture. And what we could assume, they're directly across from each other, so I know that they are vertical angles. So I knew that they were congruent because of vertical angles. Now the last one that we have to fill in says that triangle VWX is congruent to triangle YZX. So this triangle is congruent to this triangle. So what we're going to do is look at our markings. So again, you want to just cover up one of the triangles and just look at one triangle. Now, so the shortest distance to get all three is from angle, side, angle. So this one was congruent because of angle, side, angle. So it's that time again where I say thank you for watching. Make sure you hit that bell, smash that like button, turn on notifications, all that jazz, buy my merch. You know the deal. Hope you enjoyed. New videos to come.